Good afternoon, everyone. My name is Omid. I'm one of the co-founders and CEO of Remedium, where we're making carbon capture commercially viable. But today, I want to tell you a story. So come back with me to January of 2020. I was in my third year of PhD. One day in the lab, I saw a new face, a visiting scholar from Canada. His name was Moji, and I was given a task to show him around Cambridge. So we headed out. I remember it was a sunny day. I know, sunny January, UK, sounds suspicious already. But believe me, it was sunny. We ended up at the cafe in front of King's College, talking, like all good PhD students, about our research. Because let's face it, as PhD students, we didn't have anything else going on in our life. Moji's PhD was on developing a new material for carbon capture. I was always skeptical of carbon capture. So I asked, Moji, why do we need carbon capture when we have renewable energy? Moji explained that 20% of all CO2 emissions comes from industries with inherent CO2 emissions, like cement, steel, petrochemical, oil, and gas. These emissions can only be eliminated with carbon capture. Then he showed me a real-life example, a chemical facility in Germany that is emitting more than 100 kilotons of CO2 per year and paying more than $2.4 million in CO2 taxes, which will increase to 5.8 million by 2050. I was shocked hearing those numbers, so I asked, why don't they just deploy carbon capture? The answer was simple. It is cheaper to just pay tax. So Moji explained that carbon capture is currently too expensive, $100 per ton to just capture CO2, excluding transportation and storage, compared with $85 CO2 tax. And if you look at the cost breakdown, you would see that 40% of that cost is associated with two things, material and energy. Then he showed me his material, lime loop, that can capture 36 times more CO2 over its lifetime than natural limestone, which cuts the material cost by more than 80%. But I still didn't know how to reduce the energy costs. I told him, Moji, I might have a solution for you. I explained that my PhD is on heat batteries. Moji looked confused. What is a heat battery? I explained a heat battery converts cheap or renewable electricity into heat and store it, so later on it can sell it to heavy industry, electrify their heat, reduce their operating costs, and fuel consumption. Moji looked even more confused. It's fine, how does that help me? My answer, 4 words, carbon capture heat battery. I explained that when we expose lime loop to exhaust gases, it captures CO2 and releases high temperature heat, which we can supply back to the host facility and enable them to have access to cheap heat. Later on, when we have access to renewable or cheap electricity, we convert electricity into heat to regenerate lime loop, so it can capture CO2 again, and in a sense, we are charging our carbon capture heat battery. Since the electricity we buy is cheaper than the value of the heat we sell, we're not just reducing the energy cost, we are converting energy from a cost to a revenue factor. This idea excited both of us and led to founding Remedium. And it all started on that sunny day. Since then, we have shown that by taking actual 2025 electricity and natural gas prices, our average cost of capture across Europe is negative $12. Yes, you heard it right. I said negative. This means that by capturing, basically by utilizing our solution, these facilities can make money from their CO2 captures. But how? Well, let's take an example. Let's take Germany. As you can see, the cost of capture is divided amongst the CapEx and OpEx, including material, electricity, and maintenance. But in addition to that, we have a revenue stream, heat sale, which in some cases not only reduces the cost of capture, it actually makes it negative and profitable. In addition to that, we have currently received 2 letters of intent from customers, including one with a consortium of 15 cement manufacturers around the world, and the second one, who is a mortar company in the UK, which will be doing a pilot project with them in January. We have tested Lime Loop for 100 cycle reaching TRL5, built a demo of carbon capture heat battery reaching TRL4, filed 2 patents, participated since last year in 5 highly selective climate tech specific accelerator programs in US, UK, and Europe, and won several international awards, about £300,000 worth. The 2 most significant one was that last June we won the Climate Impact Prize by Net Zero Technology Center, given to the company with the highest commercial and climate potential impact. And last November we participated in Slingshot competition, which is a global competition. This year they had 6,800 applicants applied to that, and we won the green technology category in that competition as well. So just to reemphasize, we are the only solution that turn carbon capture from a cost to a revenue. But on top of that, we produce food-grade CO2 with market value of $200 per ton, and our process is waste-free because because our material Lime Loop is converted into cement after its lifetime. So let's go back to the example. If this facility buy one of our units, that unit can provide 8.8 gigawatt hour of heat, about 3 to 4% of their annual heat demand, and 3.5 kiloton of CO2 capture. That means that given the reduction in the fuel consumption, basically the heat costs and operating costs, and also the ETS tax, they get their money back in less than 7 years. But this facility is also close by a Coca-Cola facility, a food-grade CO2 uptaker. So if instead of storing the CO2, they sell the CO2 to this Coca-Cola facility, the payback period drops to only 2 years. We have also been able to put together a very capable team. It speaks for itself. We have PhDs, postdocs, MBAs from Cambridge, Oxford, MIT, INSEAD, with more than 100 years of accumulated experience in relevant research, including hydrogen, carbon capture, electricity storage, relevant industries, including working in oil and gas, petrochemical industries, cement, steel industry, and all the core team have prior experience of working in deep tech, hard tech, clean tech startups. We are currently raising our pre-seed round, 1.5 million, to do 3 things: manufacture Lime Loop at ton scale, do a live flue gas test of Lime Loop, increasing TRL to 7, and demonstrate the whole solution at a kilowatt hour at the mortar company that I mentioned, and increase the TRL of the whole solution to TRL5. By the way, here's a photo of me and Moji on that day. You see, I told you it was sunny. So now tell me, what do you do on a sunny day in January? You step outside so you don't miss it, right? Same applies here. If you're interested, please reach out.